Thank you. Nice to see you, everybody. My name is Jules from QDI Systems. I'm the CBO, and we are a company based out of the north in the Netherlands, in Groningen. And we develop quantum dot SWIR sensors and cameras. So a bit about what we do. We have the full process in-house, which means we synthesize quantum dots. We make a solution processable ink out of it. And then we process them into a film. And that could be a CMOS or a TFT sensor in the case of X-ray. Important to say is we all do this currently on a single die processing with the intention to be somewhere mid next year ready for limited capacity of wafer level processing. So a bit about the company's focus. We currently focus on 3 application areas: direct X-ray, where we want to serve medical and industrial businesses, indirect X-ray, and SWIR, which is the talk mostly today. And there we serve basically machine vision, consumer electronics, and the security market. A bit about the sensor we use. We currently use a 512 by 512 pixel sensor, which we got in a collaboration with CSEM from Switzerland. It has a pixel pitch of 22.5 micron and a global shutter with 30 frames per second. Important to mention is that we do work with multiple sensor companies to develop quantum dot sensors. But in general, this is the kind of structure we would like to see to build a successful sensor stack with quantum dots. At Vision, this is actually our first time we show our demonstration camera. This is a SWIR camera based on the sensor that we just showed you. It has the QD stacks deposited on the single chip. There's no encapsulation or cooling, which is quite good for the results I will show you later. And important to mention, it is RoHS compliant. We currently work with lead sulfide quantum dots with future developments on lead-free. The spectral range goes from 350 to actually 2000 nanometers at this moment, and that's what we're working on. And it also is available for an X-ray configuration. So we currently operate at a dark current of around 100 nanoamps per square centimeter, and at a 40% EQE. Obviously, these EQE peaks we can tune as we see the size of the quantum dots. In the second part of the presentation, I will show you some application examples. I hope the videos will actually run. No, they don't. So we did do some trials on using SWIR for sorting food like coffee beans from stones, and it works quite nice. We also did a trial on bottle filling lines. You see our experimental setup in the office. But it works really nice with our camera, and I truly invite you to come and see our booth for further demonstrations. The camera is there. We also did some wafer inspections, and you can perfectly see through the wafer and the structures behind it. So that works really well. I'm afraid this video will, yeah, it will play. There's also a good thermal response to the sensor. So here we did an experiment with a flame in the visible light and in the SWIR in 1550. And you can see that it's definitely a different image in the 1550. And also you can see the pipette will actually glow in the 1550, and it will not glow in the smartphone. So there's definitely good thermal sensitivity to this type of sensor. Yeah, SWIR is also known for security and defense to look through smoke. So here we did an experiment with some toys and some mosquito repellent sticks to create smoke. And actually, if you see the bottom, the box is entirely full of smoke. You cannot see anything. But with a SWIR image on the right side, you can see actually through the smoke, which proven to be very useful for defense, security, but also firefighting applications. I think important to mention is that with quantum dots, we think we can bring a wide spectral range to our customers. We can also be very competitive, which means there can be new application areas for SWIR beyond the current gold standard of InGaAs, which is quite a costly solution. And what we want to offer, our core business is QD material plus wafer processing. But we do have partners in the ecosystem. So we do have CMOS design companies that we work with. We do have fabs that we have connections with. We do work with companies to do the post-processing on our wafers. But also we work with a company local and internationally on the camera module and the optical system integration. So in short, we think we are the leader in SWIR quantum dot technology. We are 15 people now. We have a nice clean room space as well in Groningen. And it is our goal to really increase the field of use for SWIR. And the technology is ready for production. So please come and visit us and let us know if you're interested. And there will be another talk where we'll be a bit more about plastic sorting during the EPIC session in Congress West, room W2 at 11:35. So check it out. Thank you.
Thank you, Yul, from QDI Systems. Questions? Mark, now it's your turn.
Thanks for the presentation. Obviously, a lot of the examples you show there is fairly standard SWIR applications, which is solved now. The trouble for adoption has been price. But what you haven't really said, you said it could be more competitive, but how much more competitive?
Yeah,
because that's the key.
Yeah, I think it's always scary to say that on stage, but I think we aim to be 5 to 10-fold more competitive compared to InGaAs sensors.
And how long will that be? Where are you now? When you get to stages, when do you expect it to?
We are talking to a customer to be a bit more in mass production as of next year, so next year.
Okay.